Using NASA's James Webb Space Telescope, a team of astrophysicists has gained the longest, most detailed glimpse yet of the void that lurks in the middle of our galaxy. They found that the swirling disk of gas and dust orbiting the central supermassive black hole, called Sagittarius A star, is emitting a constant stream of flares with no periods of rest. Using Webb's NIRCam, the near-infrared camera, to observe Sagittarius A star for a total of 48 hours in 8 to 10 hour increments across 1 year, astronomers saw constantly changing, bubbling brightness, and then suddenly a big burst of brightness popped up. Then it calmed down again. They couldn't find a pattern. It appeared to be random. The activity profile of the black hole was new and exciting every time that the astronomers looked at it. While the team expected to see flares, Sagittarius A star was more active than they anticipated. The observations revealed ongoing fireworks of various brightnesses and durations. The accretion disks surrounding the black hole generated 5 to 6 big flares per day, and several small subflares, or bursts, in between. Although astrophysicists do not yet fully understand the processes at play, they suspect 2 separate causes are responsible for the short bursts and longer flares. They believe that minor disturbances within the accretion disk likely generate the faint flickers. Specifically, turbulent fluctuations within the disk can compress plasma to cause a temporary burst of radiation. For the big, bright flares, astronomers think the cause is magnetic reconnection events, a process where 2 magnetic fields collide, releasing energy in the form of accelerated particles. Traveling at velocities near the speed of light, these particles emit bright bursts of radiation. These new findings could help physicists better understand the fundamental nature of black holes, how they interact with their surrounding environments, and the dynamics and evolution of our own galactic home.